Okay, so for problem number 18, it says we have a spring and it's connected to an object and we want to displace the object 2 centimeters. So, and the spring has a spring constant of 30 newtons per meter, and we want to displace it or move it 2 centimeters or 0.02 meters. And then the question in the textbook says, how much work is done to do this? Well, the formula for work for springs is 1/2 times the constant times the displacement squared. Okay? And so this is really a kind of a plug and chug question. We just got to plug it in. And where this comes from is that if I were to graph, remember that work is equal to the force times displacement. So here's the interesting thing about springs. My force is equal to K times X, and then this value is X. So as X increases, so does F of X. So you kind of get this thing here. Well, the work that's done is the area under the curve, which happens to be a triangle, right? So the area is what we really need. So work equals the area under the curve or the area of the triangle that we see here. This is actually a calculus concept. Well, rather than do calculus and take the integral of this thing, really the only thing we need to do is just kind of use a little bit of work knowing what geometry is. So remember that the area of a triangle is just equal to 1/2 times the base times the height. And that means that this point here is going to be x comma kx. So the distance from here to here is actually x, and the distance from here to here is actually kx. So our formula is 1/2 x times kx, or the formula for work is 1/2 times x squared. Does that make sense? Now in the test, if you just memorize this, it will be good for that. Okay, but this is where it's derived from. Okay, so now anyways, to figure this out, the work that's done is 1/2 times the constant, which is 30. Boy, why do I keep writing m's there? 30 newtons per meter. And then we have 0.02 meters squared. If you plug that in your calculator, it's not a very big number, but it works out to be 6.0 times 10 to the negative 3 joules. Okay?